We're the IronMechs from Haymarket, Virginia, and this is how we learned how to use the GPS sensor with VR skills.
Hey Daniel, run the autonomous.
Okay, Eddie, I'm starting it.
The challenges that we had with the inertial sensor were that the code makes it challenging to turn to 0 degrees. It's hard to attach to the robot, it needs to be in the center of the drivetrain. It needs time to calibrate before testing code, making code take longer, and the heading can be difficult to find, especially when the robot is backwards.
The GPS sensor offers consistency and accuracy even if your code goes off course. The sensor can be attached in a variety of different places on the robot. The GPS sensor helps coding efficiency and speed because you get to the same spot every time. You can use the GPS sensor in VR coding so you don't have needed access to a vector field to test the code. Method is a method that makes it way more efficient to drive. It works by doing the normal drive if the drive distance is greater than the current position. Otherwise, it will run where the value is greater than the current position. It will run the negative way. The method I used are intake and outtake methods. These methods make it more efficient to code and understand. I made this method by placing the current intake code in the def statement. Our code makes the intake spin for 2 to 3 seconds using the wait time variable.
Our starting position starts at location E with the robot facing north with the preload in and the other preload at location 5.
Step 1 of the code consists of driving up to the goal and turning to the goal. Next, the robot outtakes a tri-ball into the goal and drives toward the second tri-ball. Step 2 consists of intaking the second tri-ball and turning it into the goal and outtaking it into the goal. Lastly, our robot turns and drives to the lineup position for step 3.
After the robot drives back to position E, it brings the arm motor down and drives towards the tri-ball underneath the elevation bar to intake it. After intaking the tri-ball, the robot isn't driving straight, so it must turn 5 degrees to drive straight across to the other side. After driving under the bar, the robot turns 90 degrees and drives towards the middle of the goal. After the robot drives to the goal with the tri-ball, it turns to the right and faces the goal. For the last part, it outtakes the tri-ball into the goal. The intake is set at 100% velocity to ensure the tri-ball is scored every time.
We learned how to code that GPS sensor in Python, meaning that we can code a GPS sensor to our actual physical robot. We learned different reasons why the GPS sensor is a good option for coding. Using VR skills helped us learn new coding methods so we don't have to go to a meeting to use our physical robot in field. With coding techniques we have from VR skills, we are currently 9th place in Virginia, have won the skills award at our last competition.